Good day, students. Welcome to our lesson this week in General Mathematics. Today we're going to discuss solving exponential equations and exponential and logarithmic forms. First, let's have solving exponential equations. Remember, if a to the x is equal to a to the y, then x is equal to y. So if they have the same base, okay? Example 1, 2 to the x is equal to 2 to the 3 or 2 cubed. So they have the same base, which is 2. So we can say that x is equal to 3. And that's the solution of that equation. Example 2, 3 to the x is equal to 9. So in order to solve an exponential equation, your goal or your always goal is to make the left side and the right side of the equation to have the same base. So in this case, the right side of the equation is 9, but we can express it as 3 square. So now we have 3 to the x equals 3 square. So they have the same base now, so therefore we can say that x is equal to 2. And that's the solution of our exponential equation. For example number 3, 5 to the x equals 1 over 625. So we can express 625 as 5 raised to 4. Okay, so now we have 5 to the x equals 1 over 5 raised to 4. But we cannot say that x is equal to 4 because in the right side of the equation, 5 raised to 4 is in the denominator. So remember, one of the law of exponent or one of the laws of exponent. So 1 over a to the x is equal to a raised to negative x, or a raised to negative x is equal to 1 over a to the x. So we can express 1 over 5 raised to 4 as 5 raised to negative 4. So now we have 5 to the x equals 5 to the negative 4. And now, so we can say that x is equal to negative 4. And that's the solution of our exponential equation. So review the laws of exponents, okay? For example, 4 raised to x is equal to 1. So remember, b raised to 0 is equal to 1. Any base raised to 0 is equal to 1. So we can say that 1 could be 4 raised to 0. So we chose 4 because 4 is also the base of x in the left side of the equation. So now we have 4 to the x equals 4 raised to 0. So x is equal to 0. Example number 5. 4 raised to 2x plus 3 equals 1. So let's make this 4 raised to 2x plus 3 equals 4 to the 0. So now they have the same base. Equate the exponents. 2x plus 3 equals 0. 2x equals negative 3. So 3 was transposed. Change the sign. Divide both sides by 2. So x is equal to negative 3 over 2. And that's the solution of our exponential equation. So for example 6, 4 raised to negative 2x times 4 to the x equals 64. So remember the law of exponent, x to the m times x to the n equals x to the m plus n. So if they have the same base, we can add the exponents. So here we have 4 raised to negative 2x times 4 to the x. So we can add negative 2x and x. So we can express this as 4 raised to negative 2x plus x. And then the right side of the equation, 64, express it as 4 cubed. So now we can equate the exponents. Negative 2x plus x equals 3. Just solve for x. So negative 2x plus x is negative x. We have negative x equals 3. Divide both sides by negative 1. So that will be x equals -3. That's how simple it is. This topic is very easy, right? Let's have another example. So example 7, 81 raised to 3n plus 2 over 243 raised to -n equals 3 raised to 4. So 81 and 243, they can be expressed as numbers with base of 4 or base of 3. Okay, so 81 can be 3 to the 4 and 243 can be 3 to the fifth power. So express 81 as 3 to the 4, so that will be 3 to the 4 times 3n plus 2. And then 243 can be expressed as 3 to the fifth power, so that's 3 to the, or 3 raised to 5 times -n. Okay, so the exponents given, 3n plus 2 and -n, I wrote it inside the parentheses to indicate that they are the original exponents, and then those 4 and 5 outside they came from 81 and 243 respectively. Okay, so this given save you the trouble. On the right side of the equation, 3 to the 4 is already given. Now, so remember the another law of exponent. But before that, we can distribute 4 to 3n plus 2. So 4 times 3n is 12n. 4 times 2 is 8. That's why our numerator became 3 raised to 12n plus 8. Then 5 times n is 5 times -n is -5n. So our denominator is now 3 raised to -5n. So remember another law of exponent. X to the m over x to the n is equal to x to the m minus n. If they have the same base and the operation is division, we subtract the exponents. So in this case, we're going to have 3 raised to 12n plus 8 minus -5n. So -5n came from the denominator, okay? So still the right side of the equation equals 3 raised to 4. Then since they have the same base, we can equate the exponents. So 12n plus 8 minus -5n equals 4. So negative and negative, that will be positive. So this will be 12n plus 8 plus 5n equals 4. So add 12n and 5n, that will be 17n, and then transpose 8. 4 minus 8 is -4. Now we have 17n equals -4. So the solution of this exponential equation will be n equals -4 over 17. So that's how it is. How easy it is. Okay. So I advise you to make your solutions step by step. Be careful so that you could arrive at the correct answer. Take it easy, okay? So for practice exercises, here are 8 exponential equations. So solve for the solution of each equation. Good luck! Now, so let's talk about the exponential form and the logarithmic form. So an expression in exponential form can be expressed in logarithmic form, and it could be done the other way around. An expression on logarithmic form can be expressed to an expression in exponential form. So for example, we have b to the x equals a. So b is the base, x is the exponent, and a is the answer. So we can express this as x equals log a base b. Again, b to the x equals a. We can express that equation as x equals log a base b. As you can see, x, so we have the exponent here, equals log a, then base is b. So technique here is read the logarithmic form. X is the exponent of b to get a. Again, x is the exponent of b to get a. Then 5 square equals 225. I'm sorry, 5 square equals 225. So we can express this as 2 equals log 25 base 5. Again, 2 equals log 25 base 5. So 2 is the exponent of 5 to get 25. And then let's have x cubed equals 27. So the exponent is 3. So 3 equals log 27 base x. Again, log 27 base x. 3 is the exponent of x to get 27. Then exponential form, algebra expression. So 6 to the y equals x plus 1. So the exponent is y. So y equals log x plus 1 base 6. Okay. Log equals, or I'm sorry, y equals log x plus 1 base 6. So y is the exponent of 6 to get x plus 1. So with continuous and repetitive practice, I think you can master this. This is very easy. If it's new to you, it will take time, but be patient. I'm sure you will be able to master this. So class, we can use logarithms to solve exponential equations. For example, let's have b to the x equals a. So to solve for x, so x equals log a over log b. So what's on the right side of the equation will be our numerator, so a, and so the numerator is log a, and then the base of x, so it will become the denominator, so log b. So x equals log a over log b. So for example, we have 5 squared equals 25. So 2 is equal to log 25 over log 5. So if you're going to try that in the calculator, log 25 divided by log 5, the answer is 2. For example, this is the given. 4 raised to x is equal to 16. So you can solve for x using logarithms. Log 16 divided by log 4. Now let's have more of solving exponential equations using logarithms. So solve this equation, round your answers to the nearest 10,000 or 4 decimal places. So for example, we have 3 raised to b equals 17. So our answer is expected to be in decimal because there is no whole or there is no exponent, a whole number exponent of 3 that could lead to 17, right? So that's why the use of logarithm here is very important and very useful. For example, 3 to the b equals 17, so our numerator will be log 17 and our denominator will be log 3. So if you have a calculator where you can encode the base, you can type this log 17 base 3, and the answer will be 2.5789. Okay, or 2 and 5,789 10,000s. Okay, but if you don't have that kind of calculator, so you can make use of logarithms. So like what I've said before, the numerator will be log 17, the denominator will be log 3. So b equals log 17 divided by log 3. And the answer is also 2.5789. So they're going to have the same answer. Another example, negative 2e raised to 7x plus 5 minus 10 equals negative 17. So we're using the natural number e here. So transpose negative 10, that will be positive 10 on the other side of the equation. So this will become negative 2e raised to 7x plus 5 equals negative 17 plus 10. Negative 2e to the 7x plus 5 equals negative 7. So divide both sides of the equation by negative 2. So that will be e to the 7x plus 5 equals 7 over 2. And then use logarithms now. Our numerator will be log 7 over 2. Our denominator will be log e. So this will become 7x plus 5 equals log 7 over 2 divided by log e. Okay? And then you can get the quotient of log 7 over 2 divided by log e using a calculator. You're going to get 1.2527629. Okay, so do not round your answer first in the nearest 10,000 because that is not yet our final answer. And then transpose 5, that will be minus 5 in the other side of the equation. That's why it will become 7x equals negative 3.747237. Then divide both sides of the equation by 7, you're going to get x equals negative 0.5353. That's in the nearest 10,000. And that is the solution of this exponential equation. The value of x is equal to negative 0.5353. So try to solve these exponential equations using logarithms. So I hope you already have your scientific calculators with you. If you don't have one, you can download scientific calculator apps to your smartphones. Many scientific calculator apps are available in App Store and Play Store. Now let's get back to the exponential and logarithmic forms. So again, exponential form, let's b to the x equals a. It is equal to x, or it can be expressed as x equals log a base b. Again, the exponential equation b to the x equals a can be expressed in logarithmic form. It can be expressed as x equals log a base b. So 5 squared equals 25. It can be expressed as 2 equals log 25 base 5. X cubed equals 27 can be expressed as 3 equals log 27 base x. 6 to the y equals x plus 1 can be expressed as y equals log x plus 1 base 6. So if the answer, or let's say x plus 1, we have here two terms, so enclose it inside the parentheses. Okay, because if you will not enclose it inside the parentheses, it will be log x base 6 plus 1, so that's a different thing. Now for some examples, some equations are given in logarithmic form. Let us express this in exponential form. So first, we have log 49 base 7 equals 2. So what's the base? The base is 7. The exponent is 2. The answer is 49. So the exponential form of this is 7 squared equals 49. Okay. For number 2, 1/3 equals log 3 base 27. Base 27, so 27 is the base, the exponent is 1/3. 3 is the answer, so this can be expressed as 27 raised to 1/3 equals 3. Another, 3x equals log 5 base y minus 1. So the base is y minus 1, the exponent is 3x, the answer is 5. So this can be expressed as y minus 1 raised to 3x equals 5. Number 4, log b minus 1 base 3 equals a plus 2. So the base is 3, the exponent is a plus 2, the answer is b minus 1. So this can be expressed as 3 raised to a plus 2 equals b minus 1. And then number 5, log 1024 base 1 half equals negative 10. So 1 half raised to negative 10 equals 1024. So kindly practice these items. Rewrite each equation in exponential form. Okay? These gibbons are easy. Always remember, class, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy. God bless everyone. See you next week for our next topic.